Two terms to understand and differentiate in this context are risk and hazard. Risk is the probability that harm, injury, or disease will occur. The probability of an adverse health effect. Whereas hazard is the potential source of harm or adverse health effect. Biological risk assessment is the process used to identify the hazardous characteristics of a known infectious or potentially infectious material or agent, and to identify the activities that can result in a person's exposure to an agent. Why do we need to do a biological risk assessment? To reduce the risk to the staff, the environment, the public, and the facility. When to do a risk assessment? There are 3 points in time when a risk assessment must be done. The first is now. It is a good idea to go through all the existing procedures in your laboratory to identify hazardous features. Next, it must be done annually to look for any issues, deviations, new techniques, incidents, etc., and make adjustments. And before setting up a new procedure. Who should do the risk assessment? The laboratory supervisor is the main responsible person. Apart from him, every laboratory personnel involved in the procedure must at least review the risk assessment. The risk assessments must be reviewed and discussed with the biosafety officer or institutional biosafety committee. The goal of risk assessment: reduce to an acceptable level the risk of worker exposure or environmental contamination. This is the ultimate goal of using the risk assessment process. You are trying to reduce the potential for laboratory-acquired infections. You must, however, understand that the risk cannot be reduced to zero. There is risk in everything that we do while working in a laboratory. Considerations for risk assessment. The first is pathogen or agent. What are the characteristics of the agent that make it hazardous? This is where the risk assessment starts. The second is procedures or protocol. The procedures being done with the organism in the vial, tube, or Petri plate. This is the second step in the risk assessment process. This is most likely the place where you would address the biosafety level to handle the agent. The third is protective equipment, such as biosafety cabinets, sealed centrifuge rotors, transport containers, biomedical waste containers, and personal protective equipment. Are all the equipment to be used operational and functioning properly? And are you trained to use it correctly? Next is place or facility. This is often the area that can be changed the least. The facility is already in place. Note the cleanliness of work surfaces, directional airflow, segregation of more hazardous procedures, etc. And fifth, the personnel. This is associated with the people who will be performing the work. Health and immune status, proficiency and experience, training, education, attitude, and new recruits are the parameters to be considered. Steps to approach risk assessment. 1. Identify the hazards. Agent risk group, procedure, facility, staff. 2. Evaluate the risk, agent and procedure. 3. Mitigate the risk. 4. Reassess the risk for any incidents or deviations. Step 1. Identify the hazards and make a list. Examples of hazard would be biological hazards like pathogenic organisms, toxins, unknown organisms that may be present in the environment or clinical samples. Step 2. Evaluate the risk using a risk matrix. It is a tool that is used during risk assessment to define the various levels of risk as the product of the harm probability or harm likelihood categories seen vertically listed in the image as almost certain, likely, possible, unlikely, or rare, and harm severity categories listed horizontally in the image as negligible, minor, moderate, major, and extreme. It is a simple mechanism to increase visibility of risks and assist management decision making. Biohazardous agents and procedures can also be classified in this manner. Risk evaluation on the basis of the agent or the pathogen. What is known about the agent? The risk group, case fatality rate, incubation period, route of transmission, transmissibility and virulence, volume and concentration, availability of post-exposure treatment, vaccine or prophylaxis, potential outcome of exposure, routes of infection, and stability in the environment. Risk evaluation on the basis of the work is done by conducting a protocol-based biohazard risk assessment. List the major procedures or processes. Break down each procedure into individual components from the start to finish. Determine hazards associated with the individual components. Look for any risk to support or maintenance or janitorial staff. Make sure that all laboratory activities are listed in the protocols. Aerosol generating activities. Procedures that impart energy into a microbial suspension are a potential source of aerosols and must be critically looked at. Examples are centrifugation, mixing with pipettes, overflow from a mixer, opening lyophilized vials, removing the top after blending or vortexing, dropping a flask of culture, dropping lyophilized culture. Worker assessment. This requires you to know your staff, their strengths, capabilities, and proficiencies, and identify training needs. Worker assessment must focus on identifying gaps, keeping in mind the worker experience and previous training, occupational health and safety, their expertise in specific protocols, good microbiological practices, their attitude towards the use of safe practices and PPE, and a new worker. So, step 3 of risk assessment is risk mitigation. After identification of hazards and its evaluation for risk. The word mitigation means reducing the severity. The hierarchy of controls that help risk mitigation are listed from the most effective to the least. First is elimination, that is, to physically remove the hazard. Next is substitution, where the hazard is replaced with a non-hazardous substitute. The third is engineering controls, where structurally the hazard is separated from people. Administrative controls, through which the way of working is changed. And last but not the least, personal protective equipment. For elimination and substitution, avoid procedures that generate aerosols as much as possible and use sharp precautions. Examples of engineering controls for risk mitigation: selection and use of proper primary barriers, biological safety cabinets, chemical fume hood, safety cups in centrifuges, sharps container, safety shower, and eye wash station. Administrative controls to mitigate risk. Have appropriate biosafety SOPs in place. Do not just put them on a shelf. Instead, practice, review, revise, and update. Every person working in the laboratory needs to be familiar with the SOPs. Conduct drills. Review standard and special practices. Recommend vaccinations. Restrict access to the laboratory. Work practice controls for risk mitigation. This requires more hands-on supervision and enforcement. No eating or drinking in the laboratory. No smoking. No handling of contact lenses. Dress code to be maintained. Lab coat hygiene and policies to be followed. No cosmetics. No handheld electronics like cell phones for entertainment in the laboratory. And jewelry considerations. Risk mitigation by personal protective equipment or PPE. PPE is the last resort after all other mitigation steps have been taken. Proper technique for donning and doffing PPE is as important as having the correct PPE. Following the selection of the appropriate PPE, balance must be struck between safety and comfort. And attend trainings on PPE. Step 4. Risk Assessment Review. Points to be considered in risk assessment review. Were there any deviations from the procedure? Were there any incidents? Is the biosafety level appropriate? Is there any new information about the agent or the procedure? Are there any new staff? Feedback from laboratory personnel? Possible improvements to the procedure? Remember that risk assessment is a continuous process. The review of the process is often required by accrediting agencies. Thank you.